All right, I'm on page 364, and this time we're going to talk about the features associated with divergent boundaries. Divergent boundaries, remember, are when two plates are moving away from one another. You can get mountains forming, but wait, Miss Goff, we said mountains form at convergent boundaries. Yes, they can also form at divergent boundaries. Now, they're different types of mountains, but we can get mountains forming at divergent boundaries. We'll talk about that in just a second. We can also get long, narrow valleys, tall, flat-topped plateaus. Okay. Now, most of our divergent boundaries are found on the ocean floor, where the sea floor is pulling apart and thinning. But divergent boundaries can also occur within a continental plate, where continental lithosphere is being pulled apart. Okay, I'm going to show you two examples of where that is occurring real quickly. Okay, so back to our map. Remember, all the yellow are plate boundaries of some sort. It doesn't really identify which type of boundary. But up here, right here, this is the country of Iceland. And there is a boundary, a plate boundary running right through Iceland. And actually, this is the North American plate. This is the Eurasian plate. And these two plates are diverging, meaning they are moving away from one another. So that means that the country of Iceland basically is slowly splitting. Okay. We also have a divergent boundary down here running through part of Africa. So this little eastern portion of Africa is actually splitting, okay, off and opening, basically opening up the continent of Africa slowly. I mean, you know, we're talking about millions of years, but there is a rift valley running through Africa because there's a divergent boundary in that, within that continent. Okay. All right. So most divergent boundaries are found on the ocean floor, but some are found on continental lithosphere also. All right. Well, what type of mountains do we get at divergent boundaries? We get fault block mountains. Okay. Faults are basically cracks. Faults form when rock breaks, and rocks break where tension at divergent boundaries is greater than the strength of the rock. So, they've told you two things basically in this sentence, that we get fault block mountains because rocks are breaking, and they reminded you that it is tension that's the type of stress at a divergent boundary. So along faults, pieces of the lithosphere called blocks either drop down or are lifted up. Blocks that drop down along faults can form valleys. Other blocks are lifted up. The blocks that are lifted up form fault block mountains, which can appear on either side of a valley. Examples of fault block mountains include the Grand Teton Mountains in the Basin and Range province of West North America. Okay. The Grand Tetons are in here in this area, okay, in western United States. Okay. Another feature, so hang on, let's do our little organizational thing. Features associated with divergent boundaries. Feature number 1, fault block mountains. Feature number 2 associated with divergent boundaries is something called a rift. In addition to mountain building, tension at divergent plates causes rifting. Rifting is the process by which Earth's lithosphere pulls apart to form long, narrow, faulted rift valleys. A well-known rift valley is the East Africa Rift. Okay. Eventually this rift will become a new divergent plate boundary. Rifting also forms rift zones. Rift zones are associated with many long, deep cracks in the Earth's lithosphere. Magma rises up through these cracks to form volcanic mountains and tall, flat-topped plateaus. Okay. So the East Africa Rift is this in here, okay? This area where the plates are, that part of the plate is, the African plate is starting to split. Okay. On the ocean floor, rifting forms mid-ocean ridges. And at mid-ocean ridges, magma rises through the cracks in the oceanic lithosphere, forming volcanic mountains. So, these mountains form an interconnected chain that runs some 60,000 kilometers along the ocean floor because they're running all over the world, under the ocean. Rift valleys run down the middle of mid-ocean ridges, and they mark the location of divergent boundaries. Okay, so most of the rift valleys that we have are actually under the ocean, and they mark the location of divergent boundaries. Okay. Let's see, there was something up here. There we go. Rifting is the process by which Earth's lithosphere pulls apart to form long, narrow, faulted rift valleys. Okay. All right, so down here real quickly, they want you to add some arrows for these fault block mountains. Okay, so this area in here is sinking. This area over here on the other side of that rock break is being shoved up. This one's being shoved up, this piece, and this one is sinking. Okay, and you get an alternating pattern like that. All right, I'm now on page 365, and we're talking about features associated with transform boundaries. We've talked about the features that are associated with convergent boundaries. We've talked about the features associated with divergent boundaries, and now we're talking about transform boundaries. Remember that it is shear stress. That's the type of stress that's going to be common at a transform boundary, because you have tectonic plates that are moving past one another horizontally and sort of scraping by one another. Okay. Rocks on either side of the boundary grind against each other, and that stress builds up and can deform the lithosphere. Okay. When rocks suddenly break along those faults, earthquakes are going to occur. So features that are common with transform boundaries are earthquakes and land features that get offset. For instance, over here you can see where a stream bed from a river or creek comes down, hits the fault, and then the rest of the river bed is way over here because that's at a transform boundary and things have moved. Okay. This part of the land has moved off to the left. This part has moved off to the right. And this is actually a photograph of a stream bed that was offset along either side of the San Andreas Fault, which is in California. Okay. And the San Andreas Fault is actually the fault that gets a lot of the credit for the earthquakes that we hear about that are occurring fairly regularly over in California. Okay. Another example of a transform boundary is the Alpine Fault that runs through the South Island of New Zealand. If you don't know where New Zealand is, it is, it's way over here on the edge of the map. But New Zealand is over here off the eastern coast of Australia. Okay. Then we have volcanic landforms that are occurring far away from plate boundaries. Most of the time we get earthquakes and volcanoes along plate boundaries because we have plates either converging or diverging. But sometimes we get volcanic islands, such as the Hawaiian Islands, that occur very far away from plate boundaries. And so they're obviously, those volcanoes are not occurring because of plate movement. Okay? They are occurring because those areas are sitting above what's called a hotspot. A hotspot is a location where magma rises from deep within the earth through the lithosphere to reach the ocean floor. Okay? And as the plate slowly moves, then the part of the lithosphere that's over the hotspot is going to move also. Okay? So you get a chain of islands that are forming. The oldest islands in the island chain are typically the ones that are farthest from the hotspot. So they were over the hotspot longest ago, and the currently active, newly forming island is the one that sits over the hotspot. Okay, and that's the way that we believe the Hawaiian Islands have formed. Okay. All right, so how does the formation of volcanoes at hotspots differ from the formation of volcanoes at convergent boundaries? Well, convergent boundaries, remember, we have volcanoes forming because one plate is being subducted underneath another one. We have some melting of that lithosphere taking place along that boundary line, causing magma to rise up and form volcanoes. But a hotspot is far away from plate boundaries, and it's just, I guess you can consider it a thinner place where the magma has been allowed to come up towards the surface and form volcanoes.